Thank you. Thank you for having me again. I'm going to speak about Azure SQL Edge with you today. And let me actually jump in because I have a lot to actually share with you today. And here's our agenda. I'm going to cover first. To understand the Azure SQL Edge, I want to explain you actually, where we are actually coming from and where we are kind of going. So I guess it will make more sense when to use the, Azure SQL Edge in IoT devices. On top of that, you kind of need to be, familiar with some other, products. Like you kind of need to know the Azure IoT Hub, Azure IoT Hub Edge. You kind of need to know what's the difference between them. You have to be familiar with the containers. So that's why I'm going to start from like basics, and we are going to kind of go from there to the SQL Edge. So before I go there, I guess let me speak about myself. My name is Hasan Savran. Currently, I'm working for one of the big insurance companies here as a business intelligence manager. And I have good experience with web development. And in my last 7-8 years, I have been doing the business intelligence in my current job. And you can actually follow me in any of those platforms. If you have any questions about any of the items here, I will be happy to answer them. Check out my blog. I have some interesting stuff out there too. So let's actually jump into our presentation. The IoT, let's talk about the history a little bit. Actual IoT idea is not really new. It came up in 80s or 90s, with like many ideas came up in 80s and 90s. And they called IoT in those days connected device. We had to wait, I believe it's 1999, by Kevin Ashton actually came up with the Internet of Things name in one of his presentations. It was a great idea, but the problem is 80s and 90s, we had to wait a good amount of time because, well, technology-wise, we were not there. And things were much expensive. And it was not easy to kind of actually do this connected device idea. So we had to wait for a couple of items to actually happen. The first thing we had to wait was the chips. The chips were expensive, and in 2010s, they started to really kind of go low, and we were able to actually use them in those, small boards. The second thing we had to wait was the connections. Wi-Fi was not really even existing in 80s and 90s, so we had to kind of wait for Wi-Fi to kind of, I guess, be a really common connection type, which was 2010s. The last thing we had to wait was the evolution from the IPv4 to 6. We had to wait for that because just basically we did not have enough IP addresses to actually make the IoT, I guess, go crazy. And we had to wait, I believe that happened in 2011s. So after those were accomplished, nothing was kind of like holding us to actually create IoT devices and put them in everywhere in our businesses. So if we actually look at the first IoT device, it was a vending machine. 1982, they connected this vending machine to their local network, and they were just checking if the items were cold in them. Then 1990 comes up, and we have the first TCP/IP connected device, which was, believe it or not, it was a toaster. Here, John Rumke is really excited about showing his toaster because he connected it to TCP/IP to internet, and he was able to control how many minutes the breads are going to be actually in the machine. Then 1991 comes up. That's our first web camera. And in another university, the students were kind of sick of because every time they go get the coffee, it was empty. So they say, okay, why don't we put like one camera here and it will take pictures, and we will connect us the camera to internet and it will send us all the pictures. And so this was actually happening, I guess, 3 times in a minute. So they can actually watch if there was coffee or not. If there was no coffee, they were going and making it. That was 1991. Then 2000 comes up, and we end up with this really complex, big item. It was the first smart refrigerator. And, well, it was really complex, and it can do all kind of stuff that many people didn't even have, that technology yet. Like you could watch a TV on it. You could actually make video calls on it. You can make all kind of like lists, and it can kind of tell you what's inside and what you need to buy. The problem was, as you can see, this price was $20,000. So that was very expensive. It was working, but it failed because it was an expensive item. But still, with 2,000, and we were able to kind of create an application and device like that. That's kind of amazing. So as you might think, if we kind of try to figure out what is IoT, really IoT is a board which has some sensors. Sensors create some kind of data, and then application usually gets this data and share with somebody, right? So from there, you have all kind of possibilities. You can do all kind of stuff with that data. So basically, that's what we are really trying to do. So if we are actually going to look, I guess, a trend, as I said before, in 2011 was the last turn point for IoT, that we actually have enough IP addresses, we have chips, we have connections. As you can see from that point, IoT number of devices grow like crazy. So in 2020, actually the estimate number right now is 50.1 billion IoT devices. Not million, it's billion, which is a crazy number. So if we actually put this graph in, I guess, like in another kind of way and look at it, here's another one. In 2020, we have almost 8 billion people on Earth, and we managed to create 50 billion IoT devices. That almost makes, almost 7 per person. But if you really think about it, there are many countries out there, they don't even have internet yet. So that number probably is much higher for people actually who has the technology. So what are those devices? Who is creating them and what categories? If you're going to create any kind of applications for them, and if your application is going to be more like residential, it's probably going to be in one of those categories here. As you can see, the smartphone is the the largest one, which is not a surprise. But you can see there are all kind of other applications and categories that probably if you are going to try to create an application for IoT device, should be probably one of those devices or the categories. If you are like doing this more like industrial, the smart city is the biggest one here. Like you can see, we have connected cars, we have like smart retail. So there's all kind of stuff happening. Like in, for example, smart city now, all the traffic lights are getting kind of controlled by the computers. They can actually watch which one, which lane has the traffic, so they can actually change the lights. Or whenever you go to airports, you have those, red and green lights. They kind of sense if there's a car out there. If there's not, it just changes the light, or they kind of tell where the green lights are to the drivers. So if you are dealing with IoT devices, and if you are thinking about creating applications and selling them, first thing you kind of need to know is there are some challenges with IoT devices. The first one is going to be the connection, right? So depending what type of application you are trying to create here, you need to pick one of those connection devices, and then write the application just specially for that. So the perfect network connectivity probably will be it will consume extremely little power. It will have a huge range, and it will have the transmit like large amount of data. That connection doesn't exist. So you end up, that's currently what we have. The first one is it's a high power consumption. It has a high range, and it has a high bandwidth. That is our cell phones. So if you think about your cell phone, it uses a lot of power. That's why you have to charge it every day. It has a high range. It can kind of connect anywhere on the world, but in the meantime, it's expensive. The second one, probably is the most common one, is the Wi-Fi or Bluetooth. Those are the low power consumption, low range, but they are high bandwidth. So if you can put like some kind of router somewhere, and your device is going to connect to that router, and you have the internet, that is the most common one, I will say, and probably cheaper one. LPWAN is low power and for the wide area network. This is mostly, if I give an example for that, I will say probably like agriculture, right? So you can put like sensors. You may want to know the temperature of the soil or something like that. So you can you are not going to really send a lot of data. Your data doesn't change that much. So you can go with LPWAN, and you will use really low power, but you will have a high range, so you can actually sense all those devices from maybe miles away. So that's another option. The other challenge with IoT devices is the security. As I said before, we have a lot of them. And you might need to kind of use some passwords to kind of maybe send the data to a database, or wherever you are sending the data. The problem is, usually developers just hard code the password out there, and they just forget about it. Because the problem is, if you have like million of IoT devices, it's not going to be easy to kind of change a password and change in each of them. Or IoT devices, those, the boards are not really like that powerful. So they cannot really have those advanced security features. You cannot really use the latest maybe encryption on them. So those are going to be the two challenges that you kind of need to deal with if you're going to, use the IoT for your applications. So I think this is a good time to introduce Azure IoT Hub. Azure IoT Hub is the place that your IoT devices can connect to, and they can send all the signals to the IoT Hub. So since we are talking about Azure now, it has to be like security has to be in a standard. So we kind of need your applications, and your IoT device has to be able to at least use the Azure security encryption. So that gives you some kind of like safe and secure platform. It's reliable, it's a cloud, it's scalable. So if today you have 1,000 devices and maybe next year you're going to have 10,000, you can actually easily change your plan. So Azure IoT Hub will be happy to have your 10,000 IoT devices next year, or it can go the other way too. So as I said before, this is the central hub. It gets all the data, but the good part about it is you can actually send data back to devices too. So it's in both ways. And as I say, it's a managed service in cloud, so there's not really that much you need to manage in that system. All you have to do is you have to just program your device so it can actually connect to the data to the Azure IoT Hub. So if you look at how much actually it costs, because that's always important. So what I'm going to actually show you here, I'm picking the free here. There are two things you kind of need to look at. The first one, how many devices do you have? The second one is how big is your message. So depending on that, you are going to be able to select one of those plans here. And as I said before, I'm going to use the free right now, and it gives me 0.5 kilobyte JSON document that I'm going to actually send. And it gives me 8,000 messages per day. So it's more than enough for them. So as I said before, you can go scale up and scale down by picking different plans here. But the best part here is, well, you are not just done after you start to send the data. There are many services, features on Azure. You can actually create pipelines from Azure IoT Hub to, for example, Event Grid. Event Grid is for critical events. For example, if you put an IoT device in your car and the car crashed and it sent the data, if your pipeline goes to Event Grid, we can call the cops or the ambulance for you. Or if it's just for like the workflow, you can actually use the logic apps. And the logic apps is for really automating the business process. You can do machine learning from the messages. You can actually process them and maybe send data back to your device. Or you can do the stream analytics. You might have a lot of IoT devices and you want to analyze that data as soon as possible. Then stream analytics is going to actually give you real-time analytics. Now, so that's Azure IoT Hub. The next item we have is Azure IoT Hub Edge. What is that? Because it's almost the same kind of name, right? So in Edge in Computer, we are actually giving more responsibility to the device. So the device maybe can make decisions or maybe store the data and do something with it rather than sending every message to the Azure IoT Hub. That gives us less network calls, and it's also more reliable because we don't need the connection all the time for this IoT device to do whatever it's doing. For IoT Hub Edge, you kind of need to be, I guess, familiar with the container containers, because all of the applications is going to be in containers. So you should know, I guess, how to run them, how to set them up. So that's something kind of you should need to know when it comes to the Azure IoT Hub Edge. So the next one, actually, I'm going to introduce you what Azure SQL Edge is. Azure SQL Edge currently is SQL Server 2019 on Linux version. But if you look at the definition of the SQL Edge, it says the latest version. So if you're going to have another, SQL Server coming up, probably that's going to be changing. Microsoft recommends that you should use Ubuntu 18.04 operation system in your IoT device to actually install this version. And when I say, Azure SQL Edge, it's really not coming up with all the SQL Server components like SSIS, SSRS, analyzing services, all those stuff. It's not coming with that. It only comes with the database engine, but not 100%. I will say maybe 80 or 90% of the database engine. For example, it doesn't have the file tables. It doesn't have the in-memory tables. So you can kind of go Microsoft and check out exactly what's in the database engine in SQL Edge. But I would say 80 to 90% is there. It requires 64-bit processor. It can be x64 or ARM64, which is the big item here. And that's why I can actually install this in a Raspberry Pi. It needs one CPU, and at least it needs 1 gig RAM. So whenever you start the SQL Edge, without doing anything, its memory footprint is going to be 450 megabytes. So you better have, depending what you are trying to do, you might need much more than 1 gig RAM. That's just the minimum, but I will suggest you at least 2 or 4 for sure. What else do we know about SQL Edge? Well, there are some items in SQL Edge that actually SQL Edge version has and other SQL Server does not have. The first one is the SQL streaming. SQL streaming is really based on the same engine that powers the Azure Stream Analytics. It just provides the real-time data streaming capabilities in Azure SQL Edge. The second one is a T-SQL function, which is its name is date bucket. And it really gives you for time series data analytics. And also, you can push AI scripts. Onyx, it's supposed to Onyx runtime. So actually, application, whatever you are running in the IoT, hub can be smart and do something without going to IoT hub. When it comes to the pricing, if you go pay as you go, it's going to be $10 per device per month. And if you're going to go reserved, it can go low as low as $60. So when I actually showed these numbers to DBAs, they got very excited because, it's really cheap if you compare to other licensing. And they started thinking that, okay, what else I can use this rather than IoT? This device is supposed to be only for IoT. So if you're going to try to use this for something else, it's against the licensing, and that's not going to be $10. Also, the billing starts when an Azure SQL Edge is deployed to the device. So if you're having issues, if it's running failed, stop, Microsoft will not care. They will always bill you for that. So you kind of need to be careful for that. So if we try to explain, I guess, the SQL Edge in an IoT device, I compare IoT devices are like babies. Babies use crying to communicate. And, well, the problem is IoT devices communicate constantly, all the time. So you end up with a constantly crying baby. What is good for crying baby is a pacifier. Pacifier, it's give you some peace. It's very useful. And agent computing is kind of like that, if you really think about it. The device is, working with less attention, and it keeps the device happy. It keeps you happy. So we have 2 types of pacifiers, and those are dev version and production version of SQL Edge. The dev version is free, and it supports up to 32 gig mem, and it supports up to 4 cores of CPU. If you go to production, it goes up to 64 gig and 8 cores of CPU. So to make this work or install the SQL Edge to an IoT device, First, actually, we have to make IoT device ready for that. So we have to install Azure IoT Edge runtime to our device first. So what really that does is it's almost like this salt and herbs that you are putting on that meat out in right side of the slide. It just makes it, I guess, more delicious, let's say it like that. So it turns your device into IoT Edge device. So your device is actually ready and is certified to connect to Azure. It can install and update any kind of workloads. If you have like any kind of security standard with the Azure, it handles that. If there is something wrong with your device, it reports back to Azure IoT Hub, so you can actually see which device is working, which one is not working. You can push containers, modules from IoT Hub to your device, so everything gets installed and loaded and get ready. And it just manages all the communication between the Azure IoT Hub and your device. To do that, there are two types of modules that actually Runtime has. The first one is IoT Edge Agent. That's the one that actually it initiates all the modules. Whenever you send, for example, in our case, we are going to send the SQL Edge. It's going to get that information. It's going to download it, install it, configure it, and everything is going to work. From there, it's going to report the status, if it's working, if it's failed. So it's going to actually do all those things. The second one is the IoT Edge Hub. So it's really act as the local proxy for the IoT Edge Hub. So the device doesn't have to connect every time for each device. And this one is the one which is reporting the status of the device, and it communicates to the cloud whenever you need it or whenever device needs to send the data. So I think we are in a good place to introduce my Raspberry Pi to you. So when I ordered this, I think it was like last summer. And it took some time for me to actually start to kind of open this and start to learn it, because it's a challenge. And it took maybe like 2-3 months for me to actually figure out what's really happening, what we are doing, try to understand what Azure IoT Edge is, what is the differences. But this is the Raspberry Pi. I took this picture when I got it first time. And I have the Raspberry Pi 4, and I ordered it with 4 gig RAM. This is the specifications of it. And when I got it, I was really amazed that, actually it had 2 HDMI. So I can actually connect 2 monitors on that thing. And you can, have a display port, camera port. You have a bunch of USB ports. So you are really good to go. You have Wi-Fi here. So the first thing came to my mind is I was like, okay, this is great, but I don't want to kind of like have a monitor just for that thing, because that thing is just small like that. And I didn't want to waste one of my monitors. So I say, okay, let's actually put this on on a network so I can actually remote in. Then I don't need to waste one of those monitors for that. The problem is I'm really not a Linux person, and this device came with Linux. So I had to find a way from Windows to, go to Linux and start to run those commands and install this runtime in this device. So I was looking for that, and actually I didn't even know that. I learned it when I was trying to install everything. But actually Windows comes with OPENSSH. To do that or to install it, first you have to go to the PowerShell, open your PowerShell, and really just add this capability to Windows. Then you don't need to, I guess, another third-party tool to connect to Raspberry Pi or any Linux device. So to do that, first, as I said before, I go to PowerShell. And you are going to need only the client here. I'm just showing you the server here because, well, it's right there too. So to add that, I am adding by the add Windows capability. I'm saying online. This is the name of the package. And from there, it just becomes available in Windows. The second I need to do is, well, I need to start the service. Then I want to be sure that the service is going to start every time my machine, starts up. So I don't need to do this manually. And also, you want to check the firewall because you don't want this behind the firewall, so you cannot connect it. So that's all I'm doing here in the third line here. I'm just being sure that everything is connectable. Then I am ready to actually connect my Raspberry Pi. To do that, I am just writing SSH. Pi is the username, and this is the IP address. So if everything is right here, I'm going to see this password. I'm going to put my password on, and I'm in right now in Pi, Raspberry Pi. And all the comments I'm going to write here is going to actually execute it in Raspberry Pi, not in my Windows anymore. So I'm very happy with this setup. And my Raspberry Pi, I connected to my router. It just stays there, and I can connect it from my desktop anytime I like. Now, before I continue, I want to say one more thing here. In older days, in PC, we used to have 32-bit CPUs, 64-bit CPUs. So if you download an application in 64-bit and try to run in 32-bit, it was not going to fly, right? This is the same thing with ARM64 and ARM32 devices. And also there's like even more kind of cases here, which I'm going to show you in a little bit. So I guess my point is, whenever you are trying to download here to install your device, you want to be sure that that application is supporting your architecture and you are downloading the right architecture. I'm saying this because the problem is if you download something wrong, the error you are going to get is not going to be a user-friendly error. It's not going to say that, oh, you know what, your CPU is ARM32, but this is ARM64, so I am sorry I cannot install this. It's not going to be like that. And you are going to waste a lot of time to figure out what's really going, happening here. I'm telling you, because it happened to me. So let's continue. The next one is you kind of need to know, as I said before, about the modules, containers. Everything is in containers. So if you're going to run an application in your device, you can use the .NET Core, create your application, but you have to put in container and push it to your device. So that's how the things kind of work. So if you are not familiar with the containers, you can learn a little bit more, and you'll be more happy with that. Also, other thing I learned, which I had absolutely no idea, was there are two tiers here that Microsoft actually supports when it comes to the devices. And Raspberry Pi is one of them. And also, when I got my Raspberry Pi, it came up with, I believe it's the Debian operation system. It was not Ubuntu. So when I actually learned that Microsoft suggests Ubuntu, I was like, well, you know what? I haven't started anything. Let me actually download Ubuntu and put in my device and start with that, which was a good idea. But the problem is, I went to the Ubuntu and it says that the latest version is 2004. I was like, well, I should get my the latest version, right? Why not? Which I did. Then I realized that actually Microsoft does not support the latest Ubuntu server. They support 1604 and 1804 as Tier 1 support. Tier 1 support means that Microsoft gives you step-by-step what you have to do to actually make runtime work in this operation system. They are not saying it's not going to work in 2004. It's just they don't have documentation for it, and they don't have repository for it. So you cannot just download everything, and it will you can write one line of code or script. It will do everything for you. So that was the case for me. Because I'm in Tier 2 here, as you can see, there are many operation systems here, Tier 2. Microsoft is saying that, you know what, they will work, but you are alone how to make that thing work. So in this presentation, I'm going to actually show you both ways. If you have Tier 1 or Tier 2, you can do both. And as you can see, 2004 is here. And it works in AMD 64, ARM32, and ARM64. So if you are lucky and you have Ubuntu 1604 or 1804, you're going to be in Tier 1. So all you have to do is you need to go get the repository file, which has all the, I guess, the location of the applications you need to. It's almost like NuGet. You get that file, and then your application knows where those files, and it just installs it right places. So what I'm doing here is I'm going this packages URL here, as you can see. And I am writing curl and really the address of the file. In this case, this is where it is, and I'm putting it in here. So what curl is, I'm not sure if everybody's familiar with Linux here. but it is client URL. All it does is it just downloads this file and puts it in this folder. Then I am running this command here, and this command just takes the same file and puts in all the sources. So whenever I try to, install something, Linux is going to look at this place to find if this does exist or not. So in that case, if I'm tier 1, it's going to find everything and it's going to install just, easily. And sudo is, I believe, do as super user. If you convert this to Windows, I guess this is run as admin. Next one we are going to need is the pretty good privacy. It doesn't matter you're in tier 1 and tier 2. This is the same. You have to do this. So again, we are just getting the file and putting it here. Then I'm moving my file to trusted where all the pretty good privacy or the encryption stuff is. That's all this one does. And this one applies to tier 1 and tier 2. Then as I said before, we are dealing with containers. When it comes to containers, Microsoft picked the Moby engine for the container engine. So you have to install the Moby engine and just put the configuration file here. Then that's it really. This one applies to tier 1 and tier 2 too. So steps are same for both. From there, if you're on tier 1, you're almost done. You get the repository, the files are. You set up the, the encryption file out there. You put the container system out there. So now you can actually install the IOTEDGE, and really you're done. If you want to actually install a different version of IOTEDGE, you can do with this comment here if you want to. Unfortunately, in my case, when I came here and say that, it says that I have no idea what IOTEDGE is. So I had to actually go and find it myself. The main reason this is not working for 2004 is because of this file. And this is the SSL capability of Linux. And this was a reference file in 1604 and 1804. And after 1804, they upgraded this file to, I believe, LIBSSL 1.5. So whenever you try to run the IOTEDGE, it's looking this file in 2004, and it cannot find it, so it throws an error. So I had to go actually find this dependency file and download it to my operation system and install it first. As I said before, look at this is the same file, but it's for different architecture CPUs here. So you really need to be careful and download the right one. And that's the one that I was talking about. The architecture is important with the CPU because it's not going to give you a user-friendly error if you pick the wrong one. So next is what I'm going to do here is I'm going to just show you how to install I'm still using the CURL here, as you can see. And I am downloading the file, and I'm saving it as the test.deb. And deb is for so much, I guess we can compare kind of with the zip files. And I'm here in depackaging the file. As you can see, after I depackage the file, I am ready to install it. To install it, I go and use the apt-get here, and I'm saying install LibSSL 1.0. So this is going to actually handle and install all the required files for IOTEDGE runtime to work. From this moment, when this is run, I'm ready for IOTEDGE. But where's IOTEDGE? Because there's no repository from Microsoft. I had to go and find it. Actually, it's on GitHub. You can go to this address here and get the latest version or whatever version really you like from here. And I get the latest version then. And I just use the URL, download the file. Then I was ready to install it by the apt-get. And that's how actually kind of looks like when you see it. After you write the install, it starts to install all the runtime files. When this is completed, we are kind of ready. Our device should be ready to connect to Azure IoT Hub. So before actually we do that, though, we have to kind of go and register our device in some way. So we have to get a connection string, right? So there are three ways to do that. The first thing is Azure Portal, which this is what I'm going to show you in this presentation. If you use WoW VS Code, there's an extension for that. It's pretty easy with that too. You just right-click on your service, and you can register an item. And the other option is Azure CLI. If you get the extension for that too, you can do it both ways. So whenever you try to register your device, they're going to ask you one question. And that question is going to be first the name of the device. Then it's going to ask you how you want to authenticate. Since I'm just doing this for dev, I'm going to pick the symmetric key authentication. This is almost like they're going to give me a kind of like a token. I'm going to put in my config file. I'm good to go. The other one is more for production. So you need a certification for that. The setup is almost the kind of same. If you think about the application, I'm in the device. You're going to actually take the both information and put in the config file of your IoT runtime application. Now, as I said before, I'm going to show you here from the Azure IoT. So in here, I create my Azure IoT Hub already service. After you are done with the service, everything is ready. You have to go here and go to IoT Edge, and you will see the icon here, add an IoT Edge device. I click here, then I'm going to have a window coming up in from the right side. It's going to give me what's the name of this device. You can name whatever you like. And here is the authentication that I was talking about. I am keeping it symmetric key. Then really from that point, I'm just clicking the submit here, and my device will be ready. So I can actually see its connection string. As you can see, when it's ready, I name it as RASP4. And when I click on it, you can see all this information. All you kind of need to do is really get the connection string here, copy it, and paste to Linux config file. So let's say we actually get this connection string from here. Then I am going to go back to Linux and run this command. This is, I'm saying, run as admin. Nano is the notepad of Linux. I'm opening this file, and you just need to find the section here and put the connection string here you got from the IoT Hub. After that, save the file. Then we can restart our runtime and check out the status. So in this case, if your connection string is right, and if you don't have any kind of problem, then you are going to see something like this. In this point, your device is going to start to actually connect the IoT Hub and give the status, like how everything is working in the modules. And you can actually go back to IoT Hub, and you can see if it's connected, if there's any problem happening. So from here, really, we are ready to push any modules to our IoT Hub to our IoT device now. How are we going to install Azure SQL Edge or any other modules? Is we are going to go back to IoT Hub. We are going to open, as you can see, this is my IoT Hub service. This is my device. So I'm going to actually go and click Set Modules this time. Then you are going to see following page. In here, there are many options. You can send your custom modules to your device, or you can get one from the marketplace. So in my case, since I'm doing this for Microsoft product Azure SQL Edge, I'm going to pick the marketplace here. Then a window is going to come from right, and I'm going to search by SQL. As you can see, there are two versions here, Azure SQL Edge Developer and Azure SQL Edge. I'm picking the developer. And really, I'm just from there, it's going to ask me some couple of questions here. If you are familiar with the containers, especially in SQL Server, well, you kind of need to give some kind of configuration so you can at least, when the installation is done, we can connect back to SQL Server. So it's going to give you what's the password for SA password for your database. So whenever everything is connected, you can connect back. And there are some other couple of things that you can actually define here. And one of them is, you want to accept this ULI. Yes, it's going to be for both. And as you can see, this is the desired value. So that's what you are really sending. And if the sent is correct, you can actually see that it's reported value. So they should match each other when everything is completed. So from this moment, we are ready to actually send this. After you save this, Azure IoT Hub is going to send this information to our device. Our device is going to go and look at it, and it's going to figure out that SQL Edge does not exist in the system. So it's going to actually go and download it, and it's going to install it. After installation, it's going to put this configuration on it. Then when that is completed, you are going to be ready to actually connect your Azure SQL Edge. So as you can see, when all those are done, I'm going to run this command here, IoT Edge list, and it's going to give you all the containers running in my device. So as you can see, Azure SQL Edge is one of them when I ran that. So I was, ready to actually connect to my server. So now let's actually see this in action. Let's do that. But first, let me actually see this. As you can see here right now, I am in my device, Ubuntu, and I ran that before, but let's run it again, IoT Edge list. And you can see that it has been running, actually it has been running much more than a week, but as you can see, everything looks fine. And next thing I'm going to do here, let's actually connect this SQL Edge. Let's see what it actually looks like. So to do that, I am going to go actually, you can go any kind of, client of SQL Server. I'm using SSMS here. So, well, actually, let's disconnect here first. As you can see, you are just going to write the name of the server. In my case, it is, this is the IP address, my local IP address, and this is the port. This is SA, and this is the password actually I write in IoT Hub. So when I connect that, I am connecting right now to this, SQL database engine in my Raspberry Pi. And let's look at the databases. I created a database out there named Sensors. So I am ready to actually get data from any kind of sensors. To get those data, you need to write a .NET Core application, which is going to get this data. Then you're going to actually push the data here. So I don't think I have any tables here. So if we create some tables, we can do that. Let's do that very quickly. So let's say we're going to get maybe OT sensor, right? Sensor data. And we're going to have a couple of columns in it. Let's say sensor ID and sensor value. Let's make that work. As you can see, you can create your data model and create the schema, just like regular SQL Server. So this is run, and if I go refresh it, I shall see my table here. Also, we have the graph tables out there too, so you can actually use the graph tables too. So here's my data. I am ready to actually push some data into this table. So I don't need to, send this data every time to IoT Hub in my case, or do something, maybe put some Onyx, AI runtime here and do something about this data when I don't have connection, for example. So, okay, let's go back here. Well, actually today, that's all I have for you today. And that was my adventure with Azure SQL Edge. And I hope everybody learned something new today.